So let's start with question 1. So question 1 says, figure 1 shows water being heated. Eventually the water changes into steam. Complete the sentences. Choose answers from the box. Each answer may be used more than once. Maybe used once, more than once, or not at all. All right, I will highlight that. I know this is just a quick answer, but that's the kind of thing that's important, is that you're not going to be forced to use the same answer, or you're not going to be forced to use two different answers. They could be the same. So let's have a look. The distance between particles in the steam is something the distance between particles in the liquid water. Well, we know that steam is hotter than water because it has more energy. As well as being hotter, the particles are going to be more spread out. So the distance between particles is going to be greater than, and we can cross that one out. Oh, no, we shouldn't cross that out because it says we can use it more than once. The distance between particles in liquid water. The density of steam is something the density of liquid water. So let's have a look. So steam is a gas. It's like this. And liquid water is going to be, random like this. So this one's going to be more dense. This one's going to be less dense. So the density of steam, which is this one, is less than the density of liquid water. Always read it back. So the density of steam is less than the density of liquid water. Absolutely. Okay, figure 2 shows how the temperature of the water varied with time. What is the name of the process that is taking place between points A and B? Well, at points A and B, here we have got a state change, because we can see that the temperature isn't increasing at that point, whereas here we've got a temperature increase. So we have to read it again. So it shows how the temperature of water varied over time. Okay, so it's water. So at this point, it's going to be a temperature increase, but this is going to be a liquid, which means that this state change is going from a liquid to a gas. So we know that the name of the process is called boiling. And what is the reason? How do we know that? Well, it's this flat line. And it's because at this point, we have a constant temperature. Okay. Okay, it's time to get our physics data sheet out. So, first off, whenever we do anything like this, we need to get our highlighter out, or just a pen and circle some of these numbers. So I'm going to do that. I'm going to use a highlighter. So we're going to mass of, and make sure you include the standard unit, because that's going to let you know if you need to convert or not. So we've got this number here, we've got this here. It wants us to calculate thermal energy, and we're given an equation, so we don't even need to look it up off the data sheet. So let's annotate this a little bit. So we've got a mass here. It's in kilograms, so that's the correct standard unit, so that's absolutely fine. We're told that this is the specific latent heat, and it's in joules per kilogram, which is good because our energy is going to be in joules and our mass is going to be in kilograms, so there's no converting to do there. It's also worth looking at how many marks it's worth. It's worth 2 marks, so if it's only worth 2 marks, there's not going to be a lot to do to it. So we've got the formula, so we can use FIFA here, so that is the formula. Next off, we're going to input our values, so let's do that. So thermal energy is what we're being asked to find. Sorry, I should have boxed that, because we really want to make sure that we identify exactly what it is that we're trying to find. So we're trying to find that, so we won't know, so we're going to leave that as E is equal to the mass, so that's 0.063. With these, because it's got all those zeros in, it's a really common error for students to miss out that zero and put something like 0.63, so just be careful, and obviously just read it slowly and then read it back once you've actually put your numbers in. I'm going to multiply that by the specific latent heat, which again is a big number, very easy to do this wrong, 260 0, 0, 0. So, read it back. E is equal to 0.063, yep, multiplied by 2, 260, 260, 0, 0. Okay. We do not need to do any fine-tuning of it. It's ready to be calculated, so we're just going to straight away go and answer it, so we don't need the F of the FIFA. So let's do that. Let's grab a calculator and figure that out. So always make sure you've got a scientific calculator to hand. So we've got 0.063 multiplied by 2, 2, 6, 0. So the hard part here is going to be typing it into the calculator correctly. So let me just check that my end was right. I like to read it backwards is normally the easiest way. So 1, 2, 3 zeros, 1, 2, 3 zeros, and then another 0, 6, 2, 0, 6, 2, and then a 2. Good. 3, 6, 0, 3, 6, 0, and so that's right. So I've got 1, 4, 2, 3, 8, 0. And make sure that you actually copy this numbering correctly. Again, it's very easy to do. 1, 4, 2, 3, 8. Oh, joules. Let's just check that it doesn't say anything like put it into significant figures or anything like that. It doesn't. Because, you know, this one here is in 3 significant figures, this one's in 3 significant figures. So 1, 4, 2, 0, 0, 0, 0, 0 would be correct. But I think we just leave it like this. Okay. We might as well leave the calculator up for the next question. Again, highlight her out. The mass of the steam was 0.063 kilograms, and the volume of the steam was 0.105 meters cubed. Now, with density, it can be in grams per centimeter cubed or kilograms per meters cubed. That's in kilograms, and that's in meters cubed. So it's dead easy for this one. So choose the units. For density, well, we've got mass divided by volume. So our mass is always going to be in kilograms, and our volume is always going to be in something cubed. In this case, meters is our standard. So we're going to end up with kilograms divided by meters cubed. So we're going to be looking for that one. And we can just write that in there. Kilograms per meters cubed. So that'll get us 1 mark out of the 3. So again, this should be a quite straightforward answer. And it wants us to calculate the density of the steam, and it's given us the formula already, so we don't even need to look it up on the sheet. So density is mass divided by volume, so we don't need to do the F. That is the F of the FIFA. All right, so the I, we're going to input it. So density we don't know, we can replace it with this row equals mass 0.063. It's in kilograms, so it's the right unit. And we're going to divide that by our volume, which is 0.105 meters cubed. So let's do that. 0.063 over 0.105 gives us 0.6. Again, just check it. 501.0 360.0. So just by reading it backwards, it makes it less familiar, and it's easier to spot if you've done anything incorrect. So that's just the rationale behind that. So I've got 0.6 kilograms per meters cubed. And again, there's nothing about standard units or writing in a number of significant figures. So that will be absolutely fine. Okay, that is the end of question 1. So I'm going to stop the video, and you can use this to check your answers before going on to question 2.